Given our basic understanding of probability from Chapter 4, we will now start to look at specific probability distributions, focusing on the discrete. But first, some definitions. A discrete random variable can only assume a whole number. Think of values related to counting. A continuous variable may assume any numerical value in an interval. In this case, think that the variable can have any number of digits to the right of the decimal place. A simple example of a discrete random variable could be seen here as the number of TVs sold in a day by a store. We know that we can only have whole numbers, not decimals. If we think of the number of customers arriving in a day at a store, there is no upper limit on the. Here you see some examples of discrete versus continuous variables. A probability distribution describes how the probabilities are distributed over the values of the random variable. And we can describe a distribution with a table or a formula. You can see there are two types of discrete probability distributions, either assigning probabilities by rules or by mathematical formulas. We can define any discrete probability distribution with a function, let's call it f of x, that provides the probability for each value of the variable. And remember our two basic rules. Each probability must be greater than or equal to 0, and the sum of all probabilities will equal 1. And remember that we can assign probabilities by three methods. But for this discussion, we will focus on the relative frequency method. Using that example of the appliance store, we can see the frequency distribution out of the 200 days studied over the number of units sold. We will deem the number of units sold as our random variable x. Calculating the relative frequency actually yields the probability, f of x, for each x value. And for this example, discrete distribution, we can represent it with a bar graph, just as we talked about in Chapter 2. Many specific discrete probability distributions can also be represented by a mathematical formula. Some of these include the uniform, binomial, Poisson, and hypergeometric. The first specific discrete distribution we will examine is the uniform, which is the simplest. The formula for the probability indicates that there is an equal likelihood of any possible outcome of the random variable x. For any discrete probability distribution, we can determine the expected value or the mean And it's simply the sum of each value x multiplied by its probability. This expected value is actually the weighted average of the values weighted by their frequency or by their probability. We can also calculate the variance of the distribution with this formula. Variance is the weighted average of the squared deviations of the random variable from its mean, and the weights are the probabilities. And the standard deviation, as you remember, is simply this positive square root of the variance. As with many of the calculations for distributions in the coming chapters, we can approach completing the arguments of the formula using a table. In this case, we multiply each x by its probability f of x and sum that column, which gives us the expected value or the mean. Expanding the table, we can calculate the columns that arrive at the arguments for the variance formula. First, we have x minus the mean, and then we square that value, and then we multiply that squared value by the probability of each x. Summing that gives us the variance, and the square root of that gives us the standard deviation.